Hi, hello and welcome. So this will be your first exercise session of mathematics, and my name is Arne, and I'll be your mathematics assistant for this year. Um, we haven't met yet, but I look forward to meeting everyone, well, next week. But for now, let's just get started on the first exercise sheet. You can find it on Canvas. If you can't find it on Canvas, then ask your fellow colleagues. Maybe you don't have permission yet to access the course. And if these problems remain, you can, of course, always send me an email. So let's get started. So I suppose that you have found the exercise sheet 1. And as you can see, at almost every exercise sheet, I start with a brief overview of the theory. This is a good place to find all the things you will need for the exercises. This is, of course, not in no way a comprehensive overview of everything you need to know from the theory, but it's all the useful bits for making exercises. So, the first things first, what do we see is sets of numbers. Well, I guess you're all familiar with them, but it doesn't hurt to quickly revise them. So everybody in first grade learned about the natural numbers, which are just, well, your normal numbers, 1, 2, 3, so on, 10,000, and so on. These are the natural numbers. And then, well, mathematicians, what did they realize? Well, you can do quite some nifty things with this. You can add them together, multiply them. But as soon as you start subtracting them from each other, you get a kind of a problem because you go below 0. So what happens then? Well, you enter into a new set of numbers, the integers. And here there is -1, -2, as well as all the other numbers we saw before. Right? Okay. So that solved our problem for minus, because well, here's this, well, we'll say also -1,000 is also in there. But, well, we haven't talked about division yet. And here comes the next nifty thing. So after the integers, which is denoted by z, we get to the integers. We get to the rational numbers. And the rational numbers are all the numbers you can make by dividing, well, natural numbers or integers with oneself. So, for example, 1/2 minus 5/6, 1/3, 13/10, and so on. These are the rational numbers. But, well, you might already hear it. If there is something rational, that also means that there is something irrational. There are also irrational numbers. And, well, maybe a story for another day, but about the discovery of irrational numbers, the guy who discovered it, well, they killed him for it because they thought it was very unseemingly to have numbers that you cannot reach by doing on one of the basic operations. So, what's one of these irrational numbers that I've been talking about? Well, the most famous one is probably pi. All heard about it. It's 3.14 and so on. And the most important thing is that it never repeats. So imagine it's not pi, I don't know them by heart, but the main important thing is that this thing here behind will never ever repeat. There is no repeating part. So, well, so 1/3, even though it will always continue till the end, there is clearly a repeating part because it's 0.3333 and so on. So it starts repeating. So it is an irrational. It's a rational number and not an irrational number. Another couple of famous ones is square root of 2 or e. All of these together make the real numbers. And then we're almost there. Well, you might already say we're missing something. We're missing minus infinity and positive infinity. Now that's true. They are not considered numbers. They are just things that we cannot count to. They're uncountable. And then we have one set on top of this. And it's the complex numbers. And these you get basically by taking the square root of a negative number. I guess in high school, for most of you, if you saw this, what does it mean? Well, it's impossible. Well, it's not really impossible because mathematicians, they don't like things that are impossible. So they found a solution to that, and it's the complex numbers. I'm not going to go too much in depth. We'll see that later in the semester, but the most important thing here is that it will be equal to 2i, this thing here. Actually, plus minus 2i. And that's a quick overview of all the sets of numbers. Once you know this, well, working with sets of numbers, you can work with subsets or much smaller sets in these kind of things. So for example, I could say like 1, 2, 3, something like this. This is also a set. It's much smaller, but you can do some operations with this. So that means you can cut in them, multiply them, do all kinds of things. And this is actually what our first exercises are going to be about. So now I encourage everyone to go to page number 5 of the exercise bundle. I'm going there as well, so bear with me. And we get to our very first exercise where we see some number lines. And these number lines, well, they are a way of noting, well, when there is something that's numbers that are, how can I say, like that, well, a part of numbers or a part of a set, you can just denote it like that. But of course, it's not very convenient to write things like that. Can you imagine reading a text and then somebody wants to say these kind of things, but, well, they always have to draw a line. So, of course, mathematicians found a solution for that, and we can write these things. So the first things first, what do we see is we'll see this number line. Let me get a different color. And there are some things noted on it. And here what's mainly is important is that you see these are open circles. So there is an open circle at 3, an open circle at 7, and there's an open circle at 12. And then, of course, I still need to, and an open circle at 12. Sorry, let me remove that. Sorry if it's a bit slow. I'm getting used to the new software, but I promise you, as you guys get better with math, I'll get better with software. So, voila. Now you can see this is all being indicated. So, between 3 and 7 and 12. So what do these open circles mean? Well, it means that everything starting from 3 all the way up to almost 7 are part of your set. So what does this mean? That means that 3 is not part of your set of numbers you're interested in, but 3.00000001 is. Everything you can think of behind 3 is part, but 3 itself not. So we can already say, well, x is going to be a part of, well, let me erase that, sorry. X is an element of, this little e means it's an element of everything between 3 and 7. So let's say we start by writing 3 and 7. Okay, and now what do we need to say is that they're part from everything between 3 and 7, but not 3 and 7 included. So how we do that is by open brackets. Open brackets, they look like this. Now, some of you might already disagree with me. They say, no. Open brackets, they look like this. They look like they're little roundy brackets. And that's perfectly fine as well. It's just what you prefer. Just if you use one style, please remain consistent. And then we're interested, well, with this 12 thing here. So we'll say, okay, this 12, all the way till the end we can count, which is positive infinity, is also going to be part. But positive infinity, as I've told you, it's not really a number, so this can never be part of it. And 12, open circle again, not part of it. And now we want to say, well, x is not only a part of this, it's not only a part of this, it's a part of both. And if you remember, or you read all the things at the beginning, well, you would know it's union. It's kind of like doing plus. Okay, so now we did our very first exercise. I'm going to tell you. In maths, it's very important that you try things for yourself. Just watching me do these exercises is not enough to truly understand what is going on. So I always encourage you to make exercises yourself. Make them along while I'm doing them. If I say we're going to make this exercise, well, just follow along. Put me on pause and try ahead for yourself. It's very important that you interact. There will be, of course, time for questions later on and all that kind of thing. But it's very important that you follow along and you make your own exercises. Okay, then let's go immediately to the next one. And that's the last one on these line curves that you can make, that we're going to make together. And we're going to say, well, everything between -8 and 2, them not included, and then, well, they are included, sorry, so we need to color these little circles. And then there is a problem here for, come on, and then there is 0 over here, and everything in between is colored. Okay, so what does this mean? It means that everything between -8 and 2, -8 and 2 are included. There's just one little hole in this entire set of numbers, and it's 0. We took 0 out. So how are we going to do that? Well, we're going to say pretty much, we're just going to start the same way. We're going to say x is an element of, and in this case, we're going to close the brackets. We're going to say -8 all the way to 2, and 2 is also included. But now we need to take 0 out. And if you remember from out, to take things out, we take basically the difference between two sets. And then what are we going to do? We're going to take out the set that just contains one element, which is 0. So that is a very first exercise. I hope this is clear. I encourage you to make the third one yourself. Actually, normally I will give you exercises to do at home. For this exercise session, I'm not really going to do that because you have to make them all at home. The things we're going to see now are so elementary that you will need them throughout the rest of the semester for every exercise we're going to make. And not only that, you're going to need them as well for understanding just basically what's going on in classes, right? So if you don't know in the lectures, if you can't read what's going on there, please always come back to this because this is really where we learn all about mathematical notation and all that kind of stuff. Okay, so let's get rid of these brackets. We don't really need them anymore. And we're going to go to exercise number 2. And in exercise number 2, we're going to make exercise A, E, and G together. So let's start with A. So A tells us we need to simplify the set of between 2 and 4 and the union between 3 and 7. So 2 and 4. Yes, I'm doing it right. And 3 and 7. Now, I'll give you some time to think about that. Go ahead, pause the video. Okay, I'm going to give you the answer right now. So basically, we have to check. So what is everything in between here? So it means that everything between 3 and 7 is there. Let me draw it out one time. So that means 3 not included, 7 included, and everything in between included. And we're going to add that because that's what union does. And then we're going to do 2 and 4. It's going to be about here, let's say. And we're going to take, well, I wrote plus here, but it's actually the union, which is just the same thing in between. And here you can already kind of see what well, the resulting set will be. They're just going to add everything together. So that means that now you're going to get something that looks like this. It's going to start from 2 and it's going to go all the way to 7. And the 3, which was a hole before, is now going to be filled by the other one. And everything in between is going to be colored. So just for clarity's sake, let me put it on with a different color. So here, here, and everything here is going to be colored. Okay, that's for A, and I hope that was clear for you. Now, let's go to E. And E, well, we're going to see something we haven't seen before. The intersection, which is basically an upside-down U. The intersection is going to take the part that's in both sets, that both sets have in common with each other. So, let's have a look. 2 and 4, and 4 included. Union, 4 and 7. So, what do these two sets have in common? Well, they actually only have one little thing in common, and this is this 4 over here. Because this only starts running at 4, and this stops at 4. So the only answer that's possible for here is 4, because that's the only element that you will find in both sets. So the union, the intersection between these two is going to be 4. Okay. Then let's go to exercise G. And here, well, we see difference again, so we get all the real numbers. So one way to write all the real numbers would be like this. Minus infinity all the way to positive infinity, of course, them not included. And what are we going to take out? We're going to take out everything between -7 included, all the way to positive infinity. Okay, positive infinity, of course, not included. So what does this mean? Well, here you get like this very colored number line. It's all the way going to be orange. And when we take out just from here, we take all of that out. So what's going to be left? Well, everything from minus infinity isn't touched. Minus infinity isn't touched because, well, we're not taking it out over here. Everything up to that point. And then at -7, something special happens. So we're going to say -7. And now I'll let you think about it. Should -7 be included or excluded from this set of equations? Well, from this set. So, because we took it out over here, because in the second set there was -7, -7 is not included anymore. So, our final answer would be this. I hope this is clear for you. So, basically we saw our major operations: union, intersection, and difference. And with this you can basically describe almost all sets if you know how to work with your brackets. Okay, then let's step it up a little bit and go to exercise number 3. And number 3, we're going to make A, C, and E. So I've drawn it out all on the number line before, but, well, there's another way of writing sets, and maybe it makes more sense to you than doing it on a number line. And it's called with Venn diagrams. And Venn diagrams is a very fancy name to say circles. Overlapping circles. So A and B. Imagine they overlap. Let's just write it. So now I drew a Venn diagram. And now we just ask ourselves the question, well, what's the union between these two? So what happens when we add these two together? What is the resulting set going to be? Well, the union between these two is going to be pretty much everything. Everything that's in A, everything that's in B, and everything that's both in A and B. This is going to be the union. Right? Okay. And then, well, exercise A is already made. Then let's go C. And here, well, this is a bit more interesting because now we have 3 sets. We have A, B, and C. Let me see if I can write this in a decent way, if I can draw this in a decent way. Yeah. I promise you my handwriting on the board is much better. So here we're interested in the intersection between A, B, and C. So what does that mean? Well, the intersection between A and B is the elements that are both in A and both in B. So it's going to be this thing over here, right? This little oval-shaped thing. And then we're going to say, well, we need to take the intersection between that and C as well. So what's actually in all 3 of the sets? And is this going to be this very tiny little thing here in the middle? It's just this. This is the only part that's in all 3 of them. And that's how intersections work. And then we can go to exercise number E. And here it's a bit of mixing and matching. And in E, we want to take the union between the difference between B and C. Maybe I should draw this a bit bigger, but well, A, B, and C. So first we want to take the difference between B and C, because that's between brackets, and what I hope you all remember, when there is something between brackets, that means that comes first. So what's the difference of B and C? Well, you basically take B and you subtract C from it. It means you take this kind of bite out of it, and it's just going to be this over here. And now what we're interested in? Well, we're interested in the union between that and A. So what do we get? And let me take even another color for that. So we're going to get, of course, everything that's in A. And then everything that was in that difference between B and C, which is all of this over here. So the entire green thing is going to be, well, the union between A and the difference of B and C. Again, please make all the other exercises at home so you're sure that these make sense to you. So you understand what these kind of sets do. Okay, then we can move on to the next exercise. And we're going to go to exercise number 4. Exercise number 4. Here, sets are defined even a little bit differently. So you see A is just 1, 2, 3, and 4. It's those 4 numbers and only those. But then B and C are a little bit, well, more special, let's say. So B says, well, x is what is true for x? Well, so x is every number that is 2 times y, where y is an element of A. So let me repeat that. It means that if we go and look at y, what is y? Y are elements of A. There are only 4 elements of A, so y can be either 1, 2, 3, or 4. And x is going to be always twice that amount. So if we draw that set, what do we get? So A we know. A we can just copy. We just say it's 1, 2, 3, and 4. And then we close the set. B is going to be just actually the multiplication of that. It's just going to be 2, 4, 6, and 8. Right? And then C is going to be the prime numbers, all the prime numbers smaller than 10. Well, I don't know if everybody knows what a prime number is, but a prime number is basically a number that you can only divide by itself and 1. Right? So what are your prime numbers? Your prime numbers are going to be 2, 3, 5, and 7. I think I have them all. Yeah, I did. Well, you might argue 1 is also a prime number, but that's up for debate. If you do that, it's not really wrong. It's not. It's up for debate. Let's put 1 here too, and let's put it between brackets. So now let's look at one of the operations that we're interested in, and the one we're going to do together is B. And B says, well, we're going to take the union between B, the set B, and the set C. So we're going to basically add all of these things together. So what do we get then? So okay, we get this 1, which might or might not be part of C. It's open for debate. Then we get 2, which is in both of them. We get 3. We get 4. 5 is also part of it. 6 is part of it. 7 is part of it. And then the last part of the 8 is also part of it. So that's going to be the union between B and C. I hope that makes sense to you. And now, of course, you can look at, well, what's the difference between A? Well, the difference of C squared from A. So that basically means you're going to square all of these and subtract it from A. Not that many numbers are going to come out. I'll tell you that now. And then A is the intersection again. So I hope this all makes kind of a lot of sense to you now. Or I hope that it's somehow clear. So, because now we're going to go to one of the most tricky exercises. Well, I know that from every year, students always think this is the hardest exercise of them all. So, this looks like quite a lot of things, and I'll give you some time to read it. You can, of course, pause the video. So, I hope you've read it by now, and it says, well, you and your fellow students, well, basically you have a question. You know some information about a group of people, and some play piano, some play guitar, some play the violin, and all kinds of combinations between those three. But you want to know who are the most talented of all the students you just interviewed. So that means that they play all 3 of the instruments. And now the trick is, well, we need to figure out which ones, well, how many there are exactly. And for this, well, please compose a Venn diagram. It's written there. This is actually kind of to help you along. So let's first start by doing that. So I'll make a big Venn diagram. So I have lots of room to write in. I hope this is much clearer than before. Voila. And then we just give them a name. And we're going to say, well, our information starts with people who play the piano. Let's start with that. Then we go to people who play the violin. And then information about people who play the guitar. So these are, well, groups of people. So the people over here would be the people who only play guitar. The people over here are the people who only play piano. The people over here are the people who play piano and guitar. And here, the people here are all the people who play all three of the instruments. And of course, so on. And when you get these kind of texts, the hardest part most of the time is just, well, distilling the information that's relevant to your question. So let's read through it together. From all surveyed students, 129 play the piano. Careful now, that doesn't mean that they only play the piano, it means that they play the piano. So this is this entire group over here. So what can we say is, well, P, the size of it, is going to be 129 students. So we know that this entire circle is going to contain 129 people. Okay, then they say 93 play the violin. So violin is going to be 93, and guitar is going to be 40. Okay, then we continue, and they say there are 188 who play the piano or the violin. Okay, so what could this mean? Well, it means that they are either in this group or they're in this group. And we have already kind of seen it, right? If we have a group that contains everything in here, well, it means that it's the union between those two. So that means when you take the union between P union B, is going to be 188. Okay, then we can continue reading, and then they say 157 play piano or guitar. So much the same, we can write it down again, and it's going to be 157. And then 123 play the violin or the guitar. Okay, so that's violin and guitar. 123. And then we have one final bit of information, and it says there are 212 who play the violin, guitar, or piano. So that means everyone, all of the students, right? So this all, the union between all of these sets is going to be 212. So we can say B union G union P is going to be 212. Okay. This is all the information we are given, and now we have to be a bit smart. So you might have remembered from high school, what do we do when we want to know something? Well, it's always a good idea to give it a name of an unknown. And in this case, well, mathematicians like to use x, so let's do it too. Let's try to find x. And of course, it's not going to be as straightforward as just subtracting some of these, but, well, it kind of is. But we're going to have to do it step by step. So the first thing we can uncover is, well, we actually can know how many people there are between this intersection here, between P and G. So we know how many people play the piano and the guitar. It could be that they still play the violin, but we don't know how many that are, because those will be all our very talented students. So how do we do this? Well, if you take the union between two parts, so you can say the union between, just a second, it was a bit too fast, so let me erase that. I'm taking out the pen again. So the union between P union G is going to be, so what's the union between these two? Well, it's going to be everything from P added together with everybody from G. By that, I think you already see a problem now. If we take everybody that's in P, which is 129 people, and we add everybody that plays the guitar, it's another 40 people, well, we're actually counting double somewhere, right? Because we're taking everybody in this circle, right? So everybody here, and we're adding this entire circle on top. So we're counting this area actually double. And that can't be that's not really what we want to do, right? So we need to take it out again. So how did we call that? Well, we called it the intersection between the two. So what can we say? Well, very, very simply, we can say minus the intersection between P and G. Okay, interesting. Well, we do know some of these things. Well, we know the union between P and G is 157, right? And we know that P was 129 big. And then G was 40 big. And then we still have this, well, intersection that we actually don't know. But that's okay with math, right? We can figure out what this is now by just bringing everything to the other side. So what we're going to get is 157 minus, because remember, positive things when they go to the other side of the equal sign, you have to do the minus, so minus on both sides of 129, minus 40 is equal to negative the intersection between P and G. Okay, and if we calculate that, you should find that this is minus 12. So minus 12 is equal to the negative value of the intersection between these two. So what can we do? We can just cancel out the negative sign on both sides, and we find that the intersection between these two is going to be 12. Okay, so that means that this entire elliptical shape is going to have 12 students in it. But of course we don't know this x, but that doesn't mean we can't write it. We can say that this is 12 minus x, right? Okay, so that means we can also say something more about P. We can say, well, P is 129 minus this part here, over here. Well, so we're not really interested in P, we're interested in this, basically where you take and divide this out. You can say it's minus 12 minus x. Minus x, because, well, of course you need to take that part out as well. And then this thing over here, we still need to do minus that, but we haven't calculated that yet. To calculate this, I'm gonna let you do that at home. So you have some time to think about this. This is something I will definitely come back to in class because I know it's tricky, but try to work this out and try to find, well, basically fill in the other spaces that we haven't done yet. Well, I'll give you a little bit more of a gift. So what we can say is this is also 40 minus 12 minus x minus x minus x minus something. This part over here. All the other stuff, the three remaining ones, well, you need to calculate them, and then you will see you haven't used this yet. This is a kind of hint how to proceed, but this will be very important to calculate x at the end. Okay, take your time, work on this now. In the meantime, I'll move along to exercise number 6, but you can just unpause me once you are ready to go on. So here, we're going to look at the laws of De Morgan. And the laws of De Morgan, maybe you're already afraid when you hear the laws of somebody because you think you're going to have to prove them. Well, we're not really going to prove them. We're just going to show visually that these things are true. So basically, all I ask you is to draw a couple of Venn diagrams and verify for yourself that these are truly the same. And I'm going to show you how to do it for A, but please, again, if you think you know how to do it, try along. So we can say A. We're going to name this A. This is B. Well, it doesn't. It's not very pretty to be. And C. And then we're going to say, well, we are interested in the difference between the union between B and C and A. So what's the union between B and C? Well, it's going to be everything in here, right? In this H shape. And that we're going to take off of A. So that means that the only thing that's in there is everything over here with this as border, right? And everything else, that's going to be your answer. Well, that's for the left-hand side. And now we want to say if that's truly equal to what's written on the other side. So let's draw the same Venn diagram again. Ooh, I made it even smaller, so it's going to be even trickier for me. Okay, let's call it A, B, and C. And in this case, well, it's written in a couple more steps. So we're going to take the difference between A and B. Okay, maybe not red, that's not the most clear. Let's do yellow. So the difference between A and B. So what is that? It's going to be everything here, right? It's just A with a chunk taken out of it, but what is B, right? Over here. And then we're going to say, well, the second thing that's in brackets, and I'll take a different color for it, and it's the difference between A and C. So we take a bite out of A using C. So it's going to be this thing over here, right? Let me make it very clear, like this. And now we're interested in the intersection between these two. So that means things that are in both sets. So basically, where it's both green and yellow at the same time. And where is that? Well, it's only in here. And then you can see, well, yeah, this is truly the same for both things. Color it red. So these and these are truly the same. I'm gonna let you try B for yourself. In the meantime, this is the end of this video. I'm gonna go on to page number 7, 8, and 9. Please make the exercises at home, and I see you in the next video.